Thank you, Diedet, for introducing me. My name is Julian van Tilburg. I work for Ecofis in the Netherlands, and I believe Diedet already introduced me. So I will continue to the presentation. The work I will present today is based on an analysis and a report we executed with a European Copper Institute, focusing specifically on 5 EU member states that use energy obligation schemes to drive their energy efficiency. Now this topic is of course a very relevant topic right now as we face the revision of the EED, and current discussions are happening in the trilogue with the European Commission, Parliament and committees, and we will face an increased energy efficiency targets over the next decade. Now, and ECI and Ecofis believe that there is potential to introduce additional energy efficiency measures that are currently underutilized in energy efficiency schemes in member states. And during this webinar, I would like to take you along in our thinking and show our findings on this topic and discuss with you this potential and also opportunities to untap this potential. Let me move to my first slide. We believe that the energy efficiency scheme is working very well. I'm showing you an example of energy savings in Italy, and you can see a steady increase in savings due to the implementation of several measures in different economic sectors like the built environment, industries, and commercial buildings, and in some member states also agricultural applications. What we observe in these energy efficiency schemes is that partly they are based on a wish to overcome barriers in adoption of energy efficiency, but also they act as a way to support innovative technologies through these schemes. Now, it is exactly the promise of these energy efficiency obligation schemes that led us to investigate the potential in different member states. And we believe that especially improvements in the evaluation protocols, measurement methods, and the pooling of expertise across different member states can even further improve this energy efficiency mechanism and obtain even larger savings in the distant future for Europe. Now, the EEO schemes have been adopted in various countries across the European Union. And you also see that countries have different types of schemes implemented. In some countries, an energy efficiency obligation scheme has been implemented, like in Poland and in Denmark. And in other countries, combinations between energy efficiency obligation schemes and alternative energy efficiency measures exist. In some countries, also only alternative energy efficiency measures are being implemented. And now for this analysis, we specifically focused on 5 member states, being Denmark, UK, Luxembourg, France, and Italy. And what we want to do in our analysis is to try and understand what works well in these countries and whether we can use these learnings to further energy efficiency across all EU member states. Now, I already mentioned that countries have different ways of implementing energy efficiency measures. What we see is that in all countries analyzed, a distinction is made between standardized measures that are collected on a list of measures with specified savings per measure. This on the one hand, and on the other hand, we see sort of non-standardized measures that can vary a lot, and the savings are typically calculated by performing audits and on-site measurements. Now, for our analysis, we specifically are interested in these lists of standardized measures because we believe that standardized measures offer a very low barrier for implementation in countries, and also these standardized measures allow the comparison between member states and also ways to distill best practices for sharing between member states. Now, this example shows you a part of the list of standardized measures that's being utilized in Denmark. Typically, these lists involve a description of a specific measure in a building, and also indicated are the savings, the energy savings associated with this measure. Now, as I mentioned, standardized measures offer a great or a low barrier for implementation, and this is also exactly what we see if we look at the most implemented measures in different countries. So this graph shows you the top 10 measures implemented in France, and actually all measures listed are standardized measures, and also standardized measures that have been implemented in buildings. So typically building insulation is a very popular one. Double glazing is popular. And the replacement of boiler systems with more efficient ones is a very popular measure. Now, this is something we see across all member states. What we're interested in is to check whether additional measures, how these are implemented in the standard list. And we identified 4 energy efficiency measures where we believe there is a high potential. And interestingly, we did not encounter these on the standard lists. And in order to show you the potential of the savings, I've indicated here the estimated percentage of savings that can be realized through implementation of these measures. So we're talking about the installation of heat pumps in buildings, the adoption of electric vehicles, replacement of conventional vehicles with electric vehicles, talking about building automation and controlling systems, and the 4th high potential energy efficiency measure is district heating. Now, all these 4 measures are captured by member states, but typically do not show up on the top lists of implemented measures, which leads us to believe that these are currently underutilized, especially if you look at the table where we list the percentages of potential savings that these measures can realize, ranging between 30 to 50% for heat pumps, for example, and 30 to 90% even for district heating. Now, it's not just the energy savings that can be realized in an individual building. We also believe that these measures have high shares of buildings or vehicles where these measures can be implemented. This is also listed in the table. You can see that between 50% and 80% implementation potential is present in the current building stock in the EU, and specifically for district heating, we also expect close to or between 30 and 50% potential. Now, I should mention that for electric vehicles, we specifically looked at the potential for light electric vehicles, which is correctly placed in the table, I should say. Looking at the graph above, one can see that these numbers add up to large totals if you look at the complete European potential. Especially the implementation of building automation and control system, the BACS, has a large potential because they are applicable in almost every building in the European Union. Now, we find it striking that these measures have large potentials, but are not currently always included in the standard measures list. We analyzed all the standard measure lists for these countries: France, Italy, Denmark, United Kingdom, and Luxembourg. And we noticed that almost all countries have some elements of these measures implemented in their standard lists, but almost no country has all of them implemented. Now, the combination of having a high energy savings potential and also still having not included those measures in the standard lists leads us to conclude that there is still underutilized potential specifically for these 4 identified measures. Now, I already mentioned at the beginning of this presentation that this is a relevant topic. Currently, the Energy Efficiency Directive is under revision, and the target for energy efficiency savings is increased to 30% for 2030. Now, we believe that insulation and boiler replacement in buildings are very effective measures, but they will only bring you so far, and we recognize the need also to include other measures in these schemes, and also look for ways of innovating in the schemes to include more measures that can be standardized and used in standardized lists to improve adoption. Now, and this is one reason why we believe that it's important to share best practices across countries. And in our analysis, we approached this by looking at the ways the energy savings are calculated for individual measures. And this we analyzed for the 5 countries I mentioned before. Now, to give you an example, this is the measure heat pump installation in buildings for the 5 for the 5 countries analyzed. The measure is not present in Luxembourg, but the other 4 member states have some variant of implementation. Now, what you can see in this table is that there are various parameters that are included in the calculation of the energy savings when this measure is installed. And for instance, the temperature of the external heat pump source, the outside temperature, the heat losses in the building, or the efficiency of the building or the technical system before the heat pump was installed. Now, interestingly, we find large differences between how these savings are calculated across countries. Countries use different parameters to calculate savings, as you can see in this table represented by the crosses. Some of these parameter choices can be explained by the country specifics. For instance, for small countries, it's not always relevant to include different climate parameters, while for other countries it is important to recognize that climate changes across the country, going from north to south. But still, ignoring these country-specific parameters, we still see that there are quite some differences across the member states in how they evaluate the energy savings. Now, as I mentioned before, we believe that sharing of best practices is important in improving the energy efficiency schemes in different member states. And we also believe that not having a comparable way of calculating savings makes it more difficult to compare between the countries. As I mentioned before, we see that each member state, not just for this measure, but for all of them, uses its own unique set of parameters to calculate savings, and we found no evidence of a supranational synchronization of the different savings realized. Now we of course understand that it's always a sort of balancing act between choosing what parameters to include in calculations and what to exclude. All countries used so-called deemed score methodology for calculating the energy savings. And while well, it is very well possible to check the way these calculations are being done, the process that leads to the deemed scores and the specific values of these deemed scores is typically undertaken by the member states themselves in a market consultation process. Now, also this element makes it more difficult to compare between different member states and also to distill best practices. Now, what we conclude from our analysis of how the different savings are calculated for measures is that there are differences between the member states, for instance, in the type of measures that are being promoted through the standard list. Measures stimulate different technologies that are related, such as heat pumps or hybrid heat pumps or ground source heat pumps. But the selection of these measures differs across countries. For instance, in France, we see that heat pumps are stimulated both in residential buildings and in commercial buildings, while for other member states, we see that the energy efficiency schemes specifically focus on residential buildings. Another example, looking at electric vehicles, 3 out of the 5 countries we analyzed focus on the adoption of electric vehicles. But this focus is on the adoption of electric vehicles for passenger cars, while we also believe that there is a potential for commercial vehicles. So this leads us to the conclusion that we see differences in the scope of measures, and we believe that the energy efficiency schemes can be improved by also taking into account additional measures like the 4 I mentioned, but also learning from other countries where measures are being implemented that are not implemented in the other country. What works well. We also, looking at the details of the calculations of savings, we also see some striking differences. For instance, one parameter that is present in all calculations is the lifetime of energy efficiency measures. And we notice that this lifetime parameter can differ by up to a factor 2 across the different member states. And this, of course, results in different deemed savings being calculated. And as I mentioned before, the specific parameter values are difficult to compare across the countries, and also the underlying calculations are typically not communicated. And this may result in also in over or underestimates of energy savings for specific cases. Looking a bit further into the details of energy efficiency calculations, we noticed that specifically for measures that involve a switch of fuel from fossil-based fuel to electricity or the other way around, a big impact on the energy efficiency savings is caused by the so-called primary energy factor for electricity. In determining the energy efficiency savings, the efficiency of the entire electricity system is taken into account. And in the generation of electricity, also quite some efficiency losses are being made. Now, interestingly, this primary energy factor is used as a fixed factor in the different energy efficiency saving calculations, while we also have the ambition in the European Union to increase the shares of renewable electricity generation. Now, over the lifetimes of these energy efficiency measures, we expect the efficiency of the electricity system to improve, which leads to a reduction of this primary energy factor. Now, the fixed value of the primary energy factor, we believe, leads to an underestimate of the total savings for measures that involve fuel switching, especially because the value of 2.5 is being used, which effectively means that electricity-based energy efficiency measures have a reduction in energy efficiency by a factor of 2.5 compared to fossil-based energy efficiency savings. We also found another structural underestimate of energy efficiency potential, and that is for electric vehicles. The calculations we analyzed use the sort of so-called standard factory test results to determine the efficiency of vehicles, not just electric vehicles, but all vehicles. While we know from various reports that the actual fuel use or electricity use in vehicles is known to deviate from these standard test results. Deviations of above 50% have been reported. Now, when switching from a conventional vehicle to an electric vehicle, this 50% mismatch effectively reduces the potential energy savings for electric vehicles. And this is one of the underestimations that we encountered in electric vehicles. And the other one is related to the lifetimes that are being used to calculate energy efficiency savings. We noticed that these lifetimes are significantly shorter than the actual vehicle lifetimes. Maybe to summarize, we have seen various differences across member states. Savings are being calculated in a unique way in the different member states, typically based on market consultation processes. And we believe that innovation in energy efficiency measures can be improved by further sharing of best practices and standardization across the member states. And we are very intrigued by the concept of having standardization guidance across the European Union, for instance, in the form of a toolbox of different measures from which member states can share best practices and also adopt the specific parameters and ways to calculate the energy savings. We envision such a toolbox to contain lists of feasible energy efficiency measures, specifically the ones that have a high savings potential. We envision the toolbox also to have guidance on how to standardize and implement these measures in the different member states, specifically identifying the potential building stocks where these measures can be most effective. We think that the toolbox should also contain strategies to do monitoring and verification of these measures, using, for instance, deemed scores methodologies in residential buildings, but also looking at other monitoring and verification strategies for commercial buildings, for instance, or buildings that deviate strongly from the sort of average building in a country. We also think that this implementation toolbox could include selected parameters to do the savings calculations. We think that current developments around the revised Energy Efficiency Directive could be a good opportunity for member states and the European Commission to develop such guidance and start discussions around standardization of measures across different member states. This concludes our findings and the slides that I wanted to share with you. Didit, I think we now have room for questions and responses from the audience.